Hello, this is Jonathan, and today we're going to be finishing off this test that I started writing. If I sound weird, I have my retainer in. That's my only explanation. I forgot to take it out. Doesn't matter. Let's see. Want to initialize tile map. It does pretty much what we want it to do, but we also need it to generate some actual data for us, so I don't really remember a whole lot about how this stuff works since it's been a while since I originally wrote this stuff, and what I basically did recently was just a sort of a refactor in a way. But if I can try and remember here, generate tile map plane is not even being used right now. This calculate tile data is kind of important. So there's a whole bunch of math happening here, and I should have commented it because it's pretty it's kind of opaque. What is why is that called TOW? Is that what it was always called? Is there a reason why it's called that? Oh, tile over width. Oh, I was like, what the heck? Why would I call that variable that? But now that actually makes sense. I don't really like it like that, but oh well. I'm just trying to remember what the heck I was doing. So we do a subtraction by 1 here. This is pretty ugly, but that is what this is doing. So subtracting 1 from the tile. I don't remember why I do that. I think that might have had something to do with a bug in tiled. No, I don't think that's right. Is it? I don't know. I remember there was a bug in tiled where it was like everything was offset by 1, and it was kind of wrong. But this might not be that. Let's see, tile sub 1 as f32 with as f32. So yeah, we're just converting stuff into floats, and we're using the modulo operator here. That should give us the x coordinate. Oh, what is this? Okay, so we get an x and a y for the tile. Oh, right, because the tile is just right. The tile is a it's just a number. So that's the thing. Let's see. All right, and this is still hard coded. I need to unhard code that. Whatever. I will do it. I swear. It's just I just need time to get around to it. I don't want to look at that because that's not where the main logic for this is. This is the main logic for that. So we calculate the tile data. We give it the width, the height, and the tile. I guess that's like an index, sort of. And I actually don't really know exactly what all this code is trying to do. This is why you document your code. Yeah, and I don't really have any like video or anything to scrub through for this because I wrote this like several years back. So that kind of sucks. Or maybe it was only a year ago. Anyway, it doesn't matter. It was like a year and a bit, I think. Like, what I could do... Well, it does have a width and a height. What is tile? Huh, right, it's one of these numbers in here. But the width and the height come from the tile set. Those are tile set dimensions. So the tile set is like the image with the tiles in it that you want to like draw your stuff from before you like paint it onto like the actual grid. So the tile set is sort of like the source. It's like it'll have like one tile for like, I don't know, like a corner of a wall, and then another tile for like the other corner of the wall, and then it'll be like a straight piece that allows you to like join the two, and then you can just like map that straight piece onto like multiple different locations on the actual map. So I'm pretty sure that's what this is doing. What this is going to do is it's going to tell me where on my tile set I should draw my tile from. Or I guess where should I, yeah, where is the graphic stored in the tile set that I should be pulling from? So with that in mind, I should be able to say, okay, so we have a tile set that has a, okay, this is the tile width and tile height. That doesn't really matter so much. That's weird. that doesn't look the way that I thought it would. Why is tile width the width of the tile, or is it the width or like the number of tiles in the tile set? I would think that would actually be the number of tiles in the tile set. Let me think about this for a moment. So, because this width and height are coming from, where are they coming from? They're coming from tile set dimensions, which isn't a tile set exactly. So where's tile set dimensions? Comes from fetch tile set dimensions, right? Okay. And fetch tile set dimensions. What does that do again? Tile set width and tile set height. Okay. So it takes, right, it divides the image width by the width of the tile to get the number of tiles basically on the x-axis, and then tile set height is the number of tiles along the height of the map. So yeah, this is what I thought it was, but it also isn't what I thought it was. So that's very interesting. Let me try and okay. So this image actually does matter then in the mock, because yeah, it does actually matter. Actually, I'm going to move all this stuff up. This is a personal preference thing, but it's kind of in the way because my actual like data is right here, and it's super annoying to have to scroll through all of this mock, all these mock definitions just so I can look at the actual data that I'm feeding into this test. So we have a 5x5 tile map. The tile width is in pixels, and the width of the actual tile set itself is also going to be in pixels. So it's going to actually be doing some math. It's going to be dividing this guy by this guy to get the number of things, tiles. Yes. Which also means I'm going to have to try and I'm gonna bring out the calculator. Gotta use the calculator. So, in this case, we're just gonna do this divide. Wait, degrees. Is this what I want? Do I want degrees? I'm not sure. I'm not doing any, like, math with, like, radians and stuff, but I guess this is okay. I think it does do what I need it to. So yeah, so this is 20 by 15. I'm gonna actually add a comment here. Oh, I feel sneeze coming on. I think it's going away. Never mind. It's going away. We're fine. I don't have to mute. Yeah, so that's this. We have the number of tiles on the x-axis is 20, and the number of tiles on the y-axis is 15. So what should happen is if I put zeros everywhere, what I think that's going to do is it's going to pull. Actually, what does that look like in the other thing? Actually, I have this tile now. I don't need to flip over to this. Yeah, I think 0 in this case is like a black square. I don't know what it is here. That's interesting. Yeah, I'm not really sure where that would go. But it is interesting. But yeah, this, if I wanted to have, like, I don't know, if my tile map looked like, I don't know, corner piece in the top left, straight piece, or I need to be able to kind of like illustrate this, I guess. So what I'm thinking right now is that my tile set looks something like oh gosh, I'm trying to draw symbols, but I can't. So that's like a corner piece. This is like the top. This is like a top right corner. You can imagine this being like walls, and then this might be like a oops, wow. This might be like the left wall. This might be an empty space in the middle, and this might be like a right wall. Like you can see where I'm going with this. So this is like 6 tiles, and the way that it would be indexed is like 0, 1, 2, 3, 4, 5. So if I wanted to have a whole bunch of like right walls, then I'd go like, oh yeah, 5s. This is like a, like if we wanted to draw like a shape in the middle here. In fact, let's just complete this entire diagram, because it's a little bit easier to see if I do that. In fact, I can even like, well, I'm not going to, but I could have thrown it in as like a comment. I'm not going to do that just yet. This is going to look something like 0, 1, 2, 3, 4, 5, 6, 7. Oops, that's not 7. That's 6 again. That and 8. And that would represent this 3 by 3 set of tiles. Now, my tile set is very big. It's 20 tiles wide and 15 tiles tall. So if this was 20 tiles, like imagine there's like a whole bunch of other tiles out here. We'll just like fill it in, etc. There'd be 20 here. So okay, that's the count, which means that this would be 0 through 19, which makes this one 20. So this guy actually is 20. So that's 20, this is 21, this is 22. This one would be, oh gosh, 20, and then another. Oh, this one should be 40. Right, it's 20 per row. So this one has to be 40. So this one will be 40. 41 and 42, if I'm not mistaken. And the rest of these zeros, I guess, they can be, I don't know. They can be 0, 1, 2, 3s. So if we imagine this as our tile map, then this is kind of what this thing would look like, I think. This is a pretty contrived example, but I mean that's the whole point, right? It's supposed to be. It's just a test. Yeah, so I'll do that a couple times and say like the structure of the tile set looks something like this. Oh, nice! It actually pastes it as a bunch of comments. That's really cool. Yeah, we'll do that a whole bunch of times again, and dot 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 that. Oh yeah, and then I guess we would also have to dot 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 down here because there's more tiles than just that. And I do believe it is indexed from like the top left corner. So this should be accurate. Not 100% sure about that, but I think it'll be accurate. Might be easier to see if I even like space this out, like the ones below. Yeah, there we go. That looks a little bit easier on the eyes. Admittedly, I could have picked a smaller mock tile set, but this is what I'm going with. And so, in the returned data here, so that's tilemap info dot. I forgot the fields of tilemap info already. There we go. Right, we have tilemap dimensions, tile set dimensions, and tilemap tiles. I think tilemap tiles is what we want to really test here. I mean, I guess I can also test the other stuff too, but the important part is that we test tile set tiles. So whoever calls this stuff, yes, tile set tiles is what we care about. Or sorry, wait, what? Did I call it tile set tiles? It should be tile map tiles, right? Yeah, tile map tiles. So let's look up tile map tiles on this guy. And tile map tiles is going to be a vector, isn't it? I think it's a tile map data vector. Yeah, tile map tiles is definitely, yeah, map tiles. Tile map tiles, yeah, that's, I'm so certain that this is some kind of a vector. Because we have this option, and then we unwrap the option basically with this OK or else. And then we map the vector. Because that's wait. Now I'm confused. Because we have a vector, and then we map it to this? Is that right? What am I mapping again? I think I'm mapping this vector. Right? Like this is, so this would be like a representation of a tile. But no, this just returns a single struct. Oh, wait a minute. This is mapping over the option. This thing doesn't unwrap it. Okay, that's... Right, because I have to return a result. I can't just return, a vector. So this still has to be wrapped in something. That's why... Right, okay. My bad. I'm just being silly again. I guess that code could be written a bit clearer. Oh well. Hindsight is 2020. So tilemap info.tilemap tiles is a vector, I believe. No, it's a tilemap tiles, and inside of tilemap tiles is a tiles. Yeah, and that's a vector. And for this, I will probably... well, I'm gonna have to do like an assert equals for each of these things, right? So... I could do like a dot... into iter dot for each. And then we can do an assert equals, I guess. Yeah, I guess so. So here we're gonna have like a tile, I guess. It'll probably be like an F32 4. That seems right. Yeah, it's expecting some kind of expression, or yeah, something like this. Oh wait, no, I don't want to for each that though, do I? I don't think that's right. No, I don't want to for each this. I'm being silly. What I should do is put this in, store this in a variable for one thing, and I am gonna explicitly type this because I feel the need to do that. It just makes this a little bit clearer for me. Let tiles equal that. All right. No? Oh, sorry. I don't know why I thought that was the right thing to do. I guess I'm so used to using type inference for everything. I'm not explicitly annotating the types is so foreign to me now. So now I can say stuff like tiles 0 equals, I don't know. Can I compare? Ooh, that's a good question. Can I even do this? Because yeah, comparing floating points is not really a thing, is it? Not really. Oh, okay. Huh. I could cast it to an integer and compare, I guess. That's one way of doing this. Oh, but then... Huh, okay. Can I compare arrays? Or is that not gonna work? Okay, first of all, I guess, my first question is, does this compile? Does this compile at all? Just let it do its thing. Because I'm kind of afraid that this thing doesn't work if I just try to compare, yeah, if I try to compare the this array of 4 floats to another array of 4 floats, it's probably not going to work too well. Okay, yeah, that does compile, it does run. Okay, this indexes into the vector. Oh boy. This is fascinating. Can I do this? I honestly don't think that's gonna work. I guess I can give it a shot. I don't even know if I really want to do that cast. Seems kind of not so good. But, you know, it's just how this works. Okay, so this would probably be 3-0. I forget what the other two those are here for. I think it's just because you have to like align the sizes or whatever. Seems legit. Right, we can actually do an assert equals here. We don't need to do this direct comparison like that. Let's try running this. I have no idea if this will work because it might not even compile. It might just say that this is not valid, and it sure as heck doesn't. Yeah, only primitives. Okay, that's what I thought. That's okay. That's okay. So that means I need to actually... Oh boy. Well, I can't compare floats. That's just... That just is a thing I can't really do. Yeah, okay. I mean, I can do stuff like this. Not the prettiest solution, but it will work. It will work. I guess what I could have done is added like a getter or something to make this a little bit clearer instead of having to index into an array, like a two-dimensional array, basically. Test failed. Ruh-roh. Left was 2, right was 3. Is that so? I guess it does, I guess it is offset by 1 for some reason. I think 0 is actually like, I'm pretty sure 0 is like, blank. Like, you just can't use 0. If I'm remembering things correctly here. I might not be. So instead of this being 0, this would have to be like 1, this would be 2, and this would be 3. Yeah, this is kind of weird. This would be 21, this is 22, and this is 23. This would be 41, 42, and 43. I think that's the way that this stupid thing works. In fact, let's look at this. So this looks at what, 6? Open this. Can I open that? Oh yeah, look at that. 0, 1, 2, 3, 4, 5. Yeah, so this is actually at position 5, but I have to use 6 because 0 maps to like a blank. So yeah, this is actually, I guess, 1 indexed. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9. Or, yeah, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 15 over here. Even though there's 14 tiles per row. So there's 14 tiles here, and the 15th tile appears down here. Okay. That makes more sense. And if I look at this, then it had 7s, which would be this guy, and then an 8, which is that top corner, and that makes sense because that would be like the top half of this little room, or not top half, but it's like this little line represents that part of the room, basically. That's all I'm trying to say. It's not hard. It really isn't. Is it? I guess I'll say 1 indexed. Zero gives blank square. So yeah, there's 20 tiles in the first row, but it's 1 index, so the tile on the next row at the beginning is 21, and 22, 23. Yeah, that makes sense. And then 41, 42, 43. Okay. That will... That's... I think that is correct now. If I am remembering. And also this is gonna fail. Because this is a 0, right? That's just not gonna work. So for the entire first row, okay, so I'm gonna actually like split this up with comments. We're gonna say this is first row. This will be 1, 2, 3, this will be 4. And they're all gonna be zeros like this. They should be. Second row. We'll just do something similar. Hang on. This should be 4. So this one should be 5. Pretty sure this is 6. Yeah, because the outer array, or vector, sorry, it's still one-dimensional. It's not... Yeah. So this row should look something like... So this one's pointing out tile 1 now, and that's this guy, right up here. So... What would the coordinate for that be? I think that's 0... No, that's not 0, 0, is it? Is that 0, 0? That shouldn't be 0, 0, but then... Oh, I actually don't remember. What happens if I don't... So yeah, what I could do is I could actually change this logic so I'm passing in the logic here for what happens. I am sorely tempted to do that. I'm not going to do that. Not right now, but I am sorely tempted to do that. I feel like that would... Well, more inversion of control is always nice, right? Alright, let's say that this is just 1, 0. This one will be 2, 0, and this one's 3, 0. I don't know how accurate that is. Let's just try running the test. Because if that's actually 0, 0, then oops. I guess I did everything wrong. I guess I did everything wrong. Yeah, that's what I thought. Okay, so these guys all map to the same thing. Huh. Then that's kind of weird. Something about this seems kind of broken? Maybe? I'm gonna have to verify this later. I don't think I've done this correctly. Either there's a problem with the algorithm. Whoa, left was actually 14? Whoa, 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 what? Okay, now I'm getting confused. Huh. Okay. This doesn't work the way I thought it does. Maybe these aren't rows. Maybe these are columns. Because why would that be 14? Right? 14 would be like the last tile on this row. I'm not reading this backwards. I'm pretty certain. Yeah, because otherwise it'd be like 1, 2, 3, 4, 5, 6. Or 0, 1, 2, 3, 4, 5, 6. 7, 8? Well, that would seem kind of backwards, right? Is there something that I'm not understanding about how this works? Because it should be the same algorithm. I don't really remember. I don't really remember how this stuff works. I'm glad I'm testing it because, yeah, it obviously doesn't. It's obviously not entirely clear. Huh. Well, I know that it worked in my original tile map example. So it's just a matter of figuring out all the dumb index math, and yeah, after that I should have an answer. But I think for now, I think that's actually just going to be it. I really need to go to sleep. I don't really want to leave it like this, especially when this doesn't even tell me which line failed. Actually, it does tell me the line number, 489. That's this one. So the Y position was actually 14. Oh, wait a minute. It starts on the bottom left, right? Because this is 15. This must be 0 and... Oh, I see. So this is 0, 0. That's why. Okay, that makes a lot of sense. That really does make a heck of a lot more sense now. So this is 0, 0. Then 6 should not be anything, right? But why does 6 map to that then? If this is 0, 0. Like, I'm not mistaken about that, right? Because I feel like I wouldn't be. Yeah, 20, 21, 21, 21. So this is 21, right? Because this was 14, so this would be 15, 16, 17, 18, 19, 20, 21. Yeah, 21 is this one. Like, that definitely seems to map out correctly. Huh. But, and yet 0 maps to this. I guess that's why there's that -1. Huh. Because otherwise this would be like 0, 1, 2, 3, 4, 5, right? Instead of 6. So if it's 0, it goes off the grid and then it jumps down here. But if it's... what are you doing? Go away. But if it's 6, then it goes up to here, -1, ends up here, picks up this tile. That is my current running hypothesis. And because it's 0 indexed down here, yeah, it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. Correct me if I'm wrong. But I feel like that's... oh, that is so wacky. I'm gonna say to do explain how indexing works with TMX. Or in TMX. There we go. So, once again, to reiterate, the height is 14 because it starts from 0 at the bottom. So this one should be 14. This one will also be 14. And this one will also be 14. I just really want to make sure I'm understanding this, because it has been a while. It has been a while since I last touched this. All tests passed. Yeah, that is how it works. Oh boy. Oh boy, oh boy, oh boy, oh boy. TMX format, everybody. Ladies and gentlemen, this is how TMX works. And I know that's how it works because this file wasn't even made by me. I didn't even like hand write out all this stuff. This was generated when I exported the TMX file. It literally put zeros here because I didn't fill in those squares. And it put the 6 here instead of a 5. Clearly because, yeah, it does this subtract by 1 and point down here at 0, 0. Or I guess I defaulted to pointing at 0, 0. But they subtract 1 and then they that's gross. That is gross. Oh, that is so confusing. That's terrible. And yet now that I know how it works again, it all makes sense. I guess. I mean, I can roll with that. I can deal. I can deal. It's fine. Also, this should say third row. So our third row is going to look, I guess, somewhat similar. So third row is going to be the left one. Where is the left one? Okay, so this is row 13. Or sorry, yeah, this is 13 now. But it's the same x coordinates, I think. Is it? It should be. Okay. Let's run this and make sure that this is correct. Show me the correctness. Yes. Okay, I understand how TMX works again. Oh boy. We're going to do fourth row. So fourth row is going to be pretty much the same as before. Again, we're just going to increment the, or I guess decrement the y. Is that right? Because we started at 14, yeah, now it's 13, and now it's going to be 12. But only for these tiles. And then the fifth row should be exactly identical to this one, except the indexes are, well, not this one, this one, yeah. So the indexes are a bit different. Wow. I finally got this stuff going again. That's super cool. Whoops, what am I doing? 23s, and now 24. Yeah, this should be called the fifth row. I'm gonna run the test. Let it do this thing, and there we go. Perfect. Everything works exactly as it's supposed to. Whew, finally. Okay, so in terms of documenting this thing, okay, I'm gonna do that right now. So indexing starts from lower left corner of tile set image. index, or I guess tile map entries have 1 subtracted from them. So 0 is the blank square. Yeah, okay. And I'm going to say tile map entries. Alright, so indexing tile map. I guess tiles starts from top left. As a result, 6 becomes 5. Yeah, here we go. Indexing starts from the lower left corner. This is tile set image. Tile map entries have 1 subtraction from them. Indexing of starts from the top left corner. As a result, 6 becomes 5. So the final chord will be something like 5. Height minus 1, I guess. I guess I can just say like 14. Yeah, because we have a concrete example right here. Origin of final chords is lower left corner of the tile set image. Yeah, there we go. I think that makes sense. Tile map entries have 1 subtracted from them, so 0 is a blank square. Indexing of tile map tile starts from the top left corner. As a result, 6 becomes 5. Which causes the final chord to be 514. Yeah, okay. I like this set of comments. I feel like this makes sense. Gosh, I forgot just how weird TMX is. Like, actually. Wait a minute. I just realized that this only allows me to create one mock map. Huh. So if I wanted to do more mock maps, that's actually not going to work, is it? Huh. Okay, I didn't think about this. I did not think about this. What could I do differently to make this better? There's definitely something I could do to make this better. Oh gosh. Okay, what I could have done differently here is, well, yeah. The thing is, it's all about create map, right? Create map creates the tile map with all the info in it, and normally I'm loading that stuff from a file. So what I could do is instead have a field for the mock inside of my mock tile map path. And then when I do the impl, yeah, because I can have different structs. I can have I have like a mock tile map path 1, mock tile map path 2, mock tile map path 3, and each of those can implement this trait, and their create maps will each of those create maps will define the mock map separately. I think that's what I should have done. I think that's what I'm going to do, because I don't really like the way that this is structured right now. This is not really helping me. It's not helping me do what I need it to do. So the mock map should be created. Actually, I don't need to do that at all. In fact, what I really needed to do here was just add mock map, and say that's a mock map. Yeah, mock map doesn't have any mock map doesn't have any type parameters. Yes, okay, good. And now I just need to return the mock map. That's all I actually need to do. Okay, I overcomplicated this. That's okay. That's fine. Oh, but then, okay, this is interesting because I only borrow self, and I need to return an owned mock map. So the only way I can do that. Okay, here's what we're going to do. This is not the greatest solution, I admit. But this is all I can think of right now. I kind of want to go to bed. It's kind of late. Oh wait, what did I just do? I did something terrible, didn't I? I just copied something without... Oh, no, I didn't. I didn't paste it. Let me go back. Go back, 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 go back. Recover. Okay. Put this down here in this test. We're gonna make let mock map equals all this stuff. There we go. Remove the comment. Oh, I already had a let mock map. Okay, well. Here we go. This is equal to that. We create a mock tile map with that. I have an idea. I have an idea. I might not need to do anything magical or special with that. I might be able to just do this. I think that could work. So instead of mock map being this, it would be this. And then I could store it in here. And then this one can call self.mockmap. Oh, well, I have to do this first because it's a member. That's right. Which will return a thing, but it doesn't actually own it. But then this thing can take ownership of the thing that's returned. Let's try that. I don't know how viable that is. That's some trickery right there. Do you see that? That right there. Man, see, this is why it's nice to be able to pass in functions and stuff all over the place. I love that. That's so nice. That right there. That was key. That was the key to victory. That's how you work around the ownership stuff for that. That is so cool. That worked. I'm super happy that worked, because otherwise I wouldn't be able to move the map out of this struct. I'd be stuck. So that's, to me, that is awesome. And I'm not bound to any one particular implementation of this function for a mock tile map path. So I don't have to have multiple structs either. I can just have one mock tile map path struct and then a customizable function here. I can just like give a different function. So this is just a function pointer. Nothing more, nothing less. And yeah, there we go. Everything works and is testable and is it's really cool. This is good progress. So the next thing I'm going to do after this, well, I actually have something I have to record tomorrow that is actually going to be based on what I've done here. So that's really awesome. But after that, I'm going to be working on testing this function next. So we're going to be doing some restructuring here to try and give this some inversion of control. And yeah, we'll be testing this so that we know that our data that we get out of this is correct. And then after that has been verified, then we're going to have to make a tile map rendering pass. And I honestly don't really know how to test that. That's something different. That's a lot harder. Because yeah, that kind of hooks into Amethyst a lot more closely than this code does. We'll see when we get there, though. We'll cross that bridge when it arrives. So yeah, that's it for today. Yeah, and if you're still watching, I don't know if there's anyone watching this, but if you are, then yeah, thanks for watching.